So R5, we're going to talk about complex fractions, and what complex fractions are. They're fractions inside fractions. So what we have is AB over CD. So instead of looking at that as a fraction, the operation, for fractions is division. So if you write it as division, then you kind of see what's going on. So really we're doing AB divided by CD, which means you do AB times DC, and that gives you AD over BC. There's two different ways to do this. We're going to do one example, and we'll do both ways with that example, and then you can kind of decide which way you like best. Okay, so this is the first. This is the first method. Okay, so we want to use this method. We would add or subtract the fractions in the numerator and denominator. So you look at the numerator separately from the denominator, and then you put them back together. So this kind of, I would say maybe is the easier way to do it. It could make a little bit more sense maybe to some of you is to just focus on the numerator, just focus on the denominator, simplify those, and then put them back together. But this second way tends to be the faster way, so we'll go through both ways and you can kind of decide which one you like best. Okay, so the second way, we find the LCD of all the fractions, and then use that to clear out all the denominators, and then we just simplify after that. Okay, so like I said, we'll go through both ways, and you can decide which way you like. I tend to do this second one, personally, but like I said, the first one might be a little bit easier, it's just going to be a little longer. Okay? Alright, so we have a fraction and a fraction here. And we'll do this using method 1 first. I'm not going to, on a test or quiz, tell you you have to use a specific method. Alright, you could choose whatever way you want to solve it. Okay, so for method 1, we do numerator and denominator separate. We take care of those. And then we put them back together. So what I'm going to do first is I'm going to write this, instead of using this fraction bar, I'm going to write the divided sign. So I'm going to write the numerator. And then I'm going to put the divided sign. And then I'll write the denominator. Okay, so I'm just going to look at this part here. I'm going to simplify the numerator of the whole fraction. So I'm going to simplify this, what's in red. Okay, so looking here, what is the LCD between x cubed and 27x cubed? Or x cubed and 27. Yeah, thanks. 27x cubed. All right. So I have to multiply this one by 27 over 27. And I have to multiply this one by x cubed over x cubed. 27 times 8, 216 over 27x cubed minus 1 times x cubed is x cubed over 27x cubed. Go ahead and subtract in the numerators. So I get 216 minus x cubed over 27 x cubed. Okay, we want to simplify our numerator as much as possible. So I don't have a common factor, but it actually does factor. I see I have a perfect cube here, so I need to check. Is 216 a perfect cube? Yes. To check, take the cube root. If it gives you a whole number, you know it's a perfect cube. What is the cube root of 216? 6. 6. So it's difference of cubes. So you need to look at how to factor difference of cubes. It's good practice for us to do. So my A would be 6, my B would be x. So it's 6 minus x, and then 6 squared, which is 36, plus 6 times x, which is 6x, plus x squared, which is x squared. Okay, nothing cancels out yet. Alright, so I simplified the left side here. So now let me look at what I have for the denominator now. The denominator of the original. I want to go back and simplify that one. Bless you. So what's the LCD here between x and 3? 3x. Good. Okay, what do you need to multiply x by to get 3x? 3. What do you need to multiply 3 by to get 3x? X. Good. So 3 times 2 gives me 6 over 3x minus, what do I get here? X over 3x. Okay, go ahead and subtract across the numerators. So 6 minus x over 3x. Any factoring I could do in the numerator here? No. So I just need to rewrite it so it's next to this one. I will put parentheses around it. Okay. So now to divide rational expressions, you multiply by the reciprocal. So I got to copy this left one down. I'm just going to copy down exactly what I have. And then I multiply by the reciprocal of the fraction to the right. So 3x over 6 minus x. Yes, did you have a question? What do you mean? How would you simplify it? No, because you're not taking a cube root of it. Like if you needed it to solve and get x by itself, maybe we'd be taking cube root, but we're not doing any solving right now. So we're just going to leave it like it is now, but I will see that I am going to be able to cancel some stuff. Okay. Any other questions? Okay. when you have a multiplication problem, you can cancel across numerators, or numerator and denominators. Just let me back up to right here. When you're subtracting or adding, so I'm looking right here. I cannot cancel these x cubes. Like, I can't do that when you're adding or subtracting. Multiplying, you can do that. Okay? Okay, so first of all, I see my 6 minus x's canceling. And then I see that, okay, 3 and 27 can cancel. So 3 becomes 1, and 27 would become 9. All right, this x will cancel with my x cubed. So x cubed becomes x squared. Okay. And then we multiply across the top, multiply across the bottom. So on the top, I'm just left with 36 plus 6x plus x squared. I'm going to write that in standard form and put the x squared first. Over 9x squared times 1, so 9x squared. So this trinomial on top came from the difference of cubes. Remember, that won't factor. Difference of cubes is set up like that. So we are done. Okay, questions about that? Alright, so that takes up a lot of space. That's a lot of work. You simplify the numerator, simplify the denominator, and then you have a division problem. Multiply by the reciprocal and simplify. Okay? Questions about how that works? Okay. So the second method, like I said, it's a little bit shorter, but it might not be as easy for you to follow. So I want you to do whichever one works out, whichever one gives you the right answer. So that means you probably need to practice some of these so you can decide which method you're going to use. Method 2 has to do with the LCD. So you find the LCD of every single denominator. I'm going to go ahead, I'm going to put parentheses around my numerator and denominator. But what I'm finding is the LCD of every single denominator. So this one, x cubed, 27, x, and 3. I have 4 little denominators in this problem. So I need the LCD between all 4 of those. Let's start with the numbers first. So what's the LCD between 27 and 3? 27. Okay, what about x cubed and x? X cubed. All right, I'm going to use this to cancel out all of my little denominators. So what I'm going to do is I'm going to multiply top and bottom by 27x cubed. So I'm still just multiplying this by 1. Nothing's changing. So I have to distribute 27x cubed to each term in the numerator. I'm going to write out the distributing for this one because I'll show you the canceling. The canceling will be a little bit easier to see. On our next problems, I'm not going to necessarily write out this step, but you can always write it out if you need to. So I'm doing 27x cubed times 8 over x cubed minus 27x cubed times 1 over 27. Okay, so this is just the distributing part that I showed. All right, let me write out the bottom one. So I'm doing 27x cubed times 2 over x minus 27x cubed times 1 over 3. Okay, so all I did was write out the distributing. Now this is what happens. So we end up being able to cancel. Okay, so here my x cubes cancel. And I'm left with 27 times 8, which I know is 216. And then the second one, my 27's cancel. So negative x cubed times 1 is negative x cubed. So that's my whole numerator. That's what my numerator becomes. And then my denominator. All right, this x cancels. That becomes x squared. So what's 27x squared times 2? $27x squared times 2? 64x squared. Okay. Here, the 3 cancels, and I'm left with 9x cubed. So negative 9x cubed times 1 is negative 9x. Okay. So what I did was I used my LCD to cancel out all these little denominators. So I took what I have here on top and made it to this. So I made it a lot simpler by doing that canceling. So the reason why we do the LCD of all of them is so every single little denominator cancels. That's what you were trying to do. Okay? Did you have a question?
Yeah, you know how before we would just go and we would put like a 27 on the first one to make it, you know what I'm saying? Does that
To get a common denominator? Yeah, that's what we did here. See? I was just missing the 27.
Okay.
Yeah. Yes, you can still do that. This is just a way to clear the little denominators and make an easier problem. Like I said, if you don't understand this way, do method 1. Okay, now I need a factor. I need to factor. I know this is difference of cubes. We just factored it when we did method 1. So that's 6 minus x over 36 plus 6x plus x squared. Now the denominator, what do I need to factor out? 9x squared. Okay, so what do I multiply 9x squared by to get 54x squared? 6. What do I multiply 9x squared by to get 9x cubed? X. Okay, then my 6 minus x's will cancel. Then I'm left with this trinomial over 9x squared. Let me write the trinomial in standard form. So even with writing out the distributing, which, like I said, I won't do this every time, writing this out. I think it's good for you to see at least once to understand what's canceling. So even with writing that out, this is shorter. But if you aren't understanding it, do method 1. Method 1, I think, makes a lot of sense. You simplify the numerator, simplify the denominator, and then divide. This one, you just clear out all your little denominators. Okay? Okay. Let's look at this problem. I'm going to use method 1 here. But first, before we do any method, I'm going to do a little bit of manipulation because I want to write this in the other order. So changing the order isn't something that you have to do, but it will make it easier to do it. So I'm going to write this here as negative y plus 5. So I changed the order. So let me cross that out so I know I'm done with that. I wrote it as negative y plus 5. And then what I'm going to do is factor out a negative 1. Because when I factor out the negative 1, I get y minus 5 and y minus 5. Okay, so hang with me still. A negative and a negative is what? Positive. So really, I can write that as 1 over y minus 5 plus 2 over y minus 5. I took those two negatives and made a positive. And then I have a common denominator in the top. So then I have 3 over y minus 5 minus 2 over y. 3 over, just copying that down. Okay, so I'm going to use method 1. So let me write this fraction as a division problem. Since these are expressions, I like to put the little parentheses around them. Okay, divided by the denominator, so 3 over y minus 5 minus 2 over y. Well, simplifying this one is easy because they already have a common denominator. So add across the top, and we get 3 over y minus 5. All right, what's the LCD for the denominator part? And y minus 5. Okay, so this 3 over y minus 5 is missing what? The y. This 2 over y is missing the y minus 5. Okay. Yes. No, wait. Here, that's subtraction.
No, why can't you just subtract 5 to make them the same from the y?
Okay. Because you can't just put a subtraction of minus 5 down here. You can't, like, if you do negative 5 over negative 5, you're multiplying by negative 5. Because you have to keep these equivalent. So what's equivalent is to multiply by 1. Okay, which is this. So putting the minus 5 and the minus 5 is saying you're multiplying by negative 5. So I have 3 times y, which is 3y over y minus 5 minus, and I want to make sure I'm distributing a negative 2. So I'm going to cross the line and change the sign there. So negative 2 is y minus 5. Here, up here? Right here? because I want to make sure that when I distribute the 2, I remember it's negative because of the subtraction. So I crossed the line and changed the sign there. So I can put them together now that I have a common denominator. So 3y plus negative 2y plus 10. You could just write 3y minus 2y too. You don't have to do plus and negative. So y, that's y plus 10. Okay, I think that's simplified then. We good? All right, let me bring this one down now. Okay, so to divide, you have to multiply by the reciprocal. Okay, cancel your y minus 5. Then you get 3 times y, which is 3y, over y plus 10. Okay. So you guys are asking each other some questions, and that's fine. But don't be afraid to ask me too, because other people might have those same questions. Yes. Oh, sure. We have one more example if you can wait.
I did it the second method and had 2y. Where did you get the 3 part?
Well, because it was, our 3 originally had come from here. Over here, this 3 came from 1 plus 2, which is 3. So you should have had y plus 2y.
Oh, I had y plus 4.
Do you see why it's 2y?
Oh, yes, I do. I
Okay.
put it to here.
Any other questions? All right, we're going to do one more and we'll use method 2. Okay, I want to use method 2, so I want to be finding common denominators of every little denominator. So I notice that I have a trinomial here. I want to factor. I want to factor so I know what this is as factors. Okay, so x squared minus 3x minus 10. What multiplies to be negative 10 and adds to be negative 3? Negative 5 and 2. Well, that's convenient because that's what I have down here. So negative 5, positive 2. So I want to find the LCD of all 3 denominators. I only have 3. Because in the top, I just have one expression. So I know I need, for this one, x minus 5, x minus 2. And now let me check the little denominators of the denominator now. So x plus 2, that's covered by this x plus 2. And then x minus 5, that's covered by this x minus 5. So I have my LCD here. Okay, so I multiply numerator and denominator by the LCD. Okay, so in the numerator, I don't have to distribute because I just have one expression. But I notice that, geez, I'm sorry. If I could read correctly here. Okay. My least common denominator is x minus 5, x plus 2. I am sorry, I'm not trying to confuse you. There we go. Yes? Okay. So here, both of these will cancel. All right, x minus 5's cancel, x plus 2's cancel. So the only thing I'm left with in the numerator is 2. So this whole numerator becomes 2. Yeah, which cancel with what I have here. So it's 2 over 1, which is 2. I am.
No, the top line.
Because I'm multiplying by x minus 5 times x plus 2, which is x minus 5 times x plus 2 over 1. Okay, this is like a whole number here.
Okay.
So here, let me write out. So if you wanted to show, that multiplication or that distributing, this is what you're doing. I'm going to erase this so we don't get confused on where it goes. So I'm doing this times this. All right, so all of those cancel, so 2 over 1 is 2. Okay? So in the denominator, I'll erase that in a minute. So watch in the denominator. Now I'm distributing this whole thing. So my x plus 2's will cancel, but I still have 6 times x minus 5. Okay, the x plus 2's cancel, but I still have 6 times x minus 5. Okay. I'm multiplying this whole thing by this one, and this whole thing by this one. I'm distributing it. So you have a minus sign here. So that's like having x plus 2. 2 different terms inside. So you multiply it times this one, you multiply it times this one. And I'm distributing. Alright, so then I have, on this one, my x minus 5's cancel, but I still have the x plus 2. So I have minus 4 times x plus 2. Okay, so what I did is I took this crazy fraction and I got it down to this. So I have 2 over, hang with me, 6x minus 30 minus 4x minus 8. Okay, so 2 over 2x minus 38. Well, I noticed I can factor out a 2. That's x minus 19. Your 2's cancel, and you get 1 over x minus 19. Okay, so it's shorter, but you have to understand the distributing and what cancels. Do we?